Our final presentation I think you're going to find very interesting. On somewhat short notice, Brian Dipert and Gregori of BDTI agreed to step up and do technology trends presentation on mobile vision. Whether or not you're actually in the mobile device market, meaning smartphones and tablets, I think you're going to find this interesting because mobile devices have become such a crucible site for so many things, for pushing semiconductor technology, pushing sensor technology, for pushing, as we heard from Shalini's presentation, pushing software development support for vision applications. So I think these mobile devices are going to really have a huge impact, not only in mobile devices in that market, but way beyond in all kinds of other applications. So let me turn it over now to Brian, who will do the first segment, and then Eric will do the second segment.
So can you all hear me? Okay, so speaking of short notice, we were originally going to have 3 presenters for this session. Myself, Eric, and Ronnie Greenberg from Eyesight. About an hour ago, Ronnie mentioned to me that he needed to go to another pressing commitment. So I'm going to take a stab at presenting his material in addition to mine. And I'm going to invite Eric and Jeff to jump in and hit up any points that I underemphasize or overlook. And we also have a soft from Point Grab in the audience who got a sneak peek at this particular section of the material, and I've invited him to jump in as well. So, embedded vision in mobile electronics devices. It's a topic that some of you might be wondering why we're covering it today. Because I realize that for only a subset of you in the audience, are directly involved in the mobile electronics business segment for embedded vision. So why are we going over this today? Well, there's at least 4 key reasons, and let me see if I can remember all of them. The first one is that some of you are directly involved in the mobile electronics business, whether it's a microprocessor company like NVIDIA or our member in progress Qualcomm, or a gesture interface software manufacturer, or a company like Aptina. Some of you are directly involved in this as an important business segment. Second key reason that I see is that software innovations that initially appear in mobile electronics devices eventually will migrate over to other embedded applications. So anything Linux-based, anything Linux-based, of course, is usable not only on a smartphone or a tablet, but also in an embedded system, with Android being probably the most obvious example of that. And of course, there are other mobile operating systems that are portable to other applications, like the real-time embedded variant of Windows 8. Third reason is that we're talking about very high volume, very fast-moving market segments here, smartphones and tablets in particular. So the feature set improvements, the price reductions, the power consumption improvements over time that begin there, all of you in other application areas sooner or later can benefit from as well. And the fourth one, and I'll use Microsoft Connect as the example here, an embedded vision breakthrough that first appears in one market segment becomes generally known, and your customers in other areas will sooner or later begin to ask for it as well. And of course, the gesture interface and the face detection and face recognition aspects of the Microsoft Connect are now becoming commonplace in a number of other system designs. Similarly, augmented reality, for example, which will probably get its initial traction in the mobile electronics market, will, I would wager and I postulate, become increasingly required and requested by customers in other embedded areas over time. So with that in mind, let me show you first off a clip from Qualcomm about their Vuforia augmented reality development system and applications. course, it ran just a few minutes ago. And of course, the sound isn't working either. There are retail applications, advertising applications, point-of-sale purchase applications, gaming applications. And these are all, of course, running on mainstream smartphone platforms that are, available for free with a 2-year contract from major cellular service providers. So, what are we going to go over today? I'm going to give you an idea of just how big the mobile market is and how fast it's growing in what particular areas. I want to talk about the hardware potential in terms of the platforms that these embedded vision applications are running on, as well as what the operating systems are capable of. And then we're going to go over 3 specific application areas in greater detail. Those being gesture interfaces, augmented reality, computational photography, which is a really interesting case study. And Shalini in the back of the room, actually. And are you going to be available to demo some of that stuff afterwards?
I have a few examples, yeah.
Okay. Shalini's got some examples running of HDR photography and other computational photography applications like panorama mode that you can see for yourself after the presentation is over. And then we're going to talk about development tools and then wrap up and entertain your questions. So I'm not going to go through all the detail on this slide, and there's even more detail in the appendix that of the presentation that you'll get in a few days via email. But so the high points here are the market is large, the market is growing, the market is increasingly Android dominant. The overall smartphone market from 2011 to 2012 actually shrunk a bit, but the smartphone percentage of that market grew about 10 points from the third quarter of 2011 to the third quarter of 2012. And note that these are sales, not shipments. Okay? So 169.2 million units sold worldwide just in the third quarter of 2012. That's around a 50% growth from a year ago, that same time. And the Android market share, from around 50% of the worldwide market in the third quarter of 2011 has jumped up to nearly 75% of the market in the third quarter of 2012. So you can see why Linux in general and Android in particular are interesting application development markets, both for mobile electronics and for embedded systems that also might use those operating systems.
Right?
Yeah.
The math not working there. Apple's 46.5% of the market, but it's only 13.9% of the shares.
ASPs.
It's the Samsung and Apple together are 46%.
Right. Yeah, Samsung and Apple together are 46.5%. Samsung alone is 32.5%.
Are these based on unit shipments or ASPs?
These are based on
Unit shipments.
unit shipments.
So if you look at ASPs, if you look at the actual revenue, not unit shipments, you'll find Apple has much higher revenue.
Yeah, what did I hear recently? Apple is estimated to have 60% of the profits for the
Yeah.
entire mobile phone industry. I mean, it's Mac OS versus Windows all over again, right? But, volume versus profit margin. The point, the key point of this foil is that tablets are real. That was still in some question a year or two ago. Again, 50% growth from the third quarter of last year to the third quarter of this year. Now, in talking with Lonnie earlier today, he did bring up the reputed, fairly substantial return rate of these tablets. So you'll note that what we're talking about here are shipments, not sales. But and at the moment, I think the return rates are particularly notable for non-iOS-based tablets. But still, this is a growing market. And again, as with smartphones, the Android percentage is growing at Apple's expense, with really Samsung and Amazon leading the charge here. Unclear, at least in the near term, how much of an impact the iPad mini with its lower pricing and the Windows 8 and Windows RT tablets are going to have on the Android increases. So, I think a lot of us already kind of conceptually know this. I certainly did before I developed this foil, but it's still pretty amazing to document it down on a slide. Mainstream smartphones and tablets have 1.5, 1.4 gigahertz dual and quad core ARM Cortex-9 and even more advanced generation CPUs. Okay? They've got multi-core shader-capable GPUs. Many of them on the same SoC have dedicated video processing and or more fuller featured DSP resources right on chip. The front image sensors are a megapixel or greater. The rear sensors are at least 5 megapixels, oftentimes even more. 1 or more gigabytes of DRAM, many gigabytes of flash memory, and equally important for cloud-based and cloud-assisted applications, robust wireless connectivity, both Wi-Fi and cellular data. And of course, along with the hardware, we're talking about robust, multitasking-capable, API-rich operating systems. So these are really, really ideal development platforms for embedded vision. So, as I mentioned before, the 3 main applications we're going to talk about in more detail today are gesture interfaces, augmented reality, and computational photography, and these are some of the subset examples of each of those. But there are plenty of others. Any of you have used Google Goggles know the power of visual-based search. There is a fundamental difference here between face detection, which says this is a human being, and face recognition, which says that's Brian Dipert and not Eric Gregori. But there are applications for both the front and rear cameras. Eye tracking is increasingly becoming useful. And then the health monitoring applications. Some of you have seen the iPad respiration and pulse rate application that we've talked about before. There are applications that will detect and alert you to abnormally formed and fast-growing moles on your skin. I mean, there's all sorts of things like this that are becoming popular in the healthcare area. This is a variation of one that you may have seen before, where the woman is in the kitchen cooking, and she's got a handful of dough, and she's not able to answer the phone by touching the screen, but she answers it by waving her hand in front of the camera phone.
핸드폰 바꾸셨네요.
So, the 2 key points of this first foil from my site, for me, in terms of the appeal of gesture interfaces, are that they're useful first and foremost in environments where touch isn't an option, whether it's because you're, like I said, you're cooking in the kitchen and your hands are full of stuff, or you're in the bathtub and your hands are wet, or you've got gloves on, or your hands are dirty or something like that. So touching isn't going to work at all. The other application is sort of a lean back type application. When you're on a tablet, you're flipping through photos, or you're watching a movie and you want to pause it and then play it, or you're playing a game and you don't want to have to touch the screen. So these, to me, are the key use cases where gesture interfaces are appealing and interesting. And this slide pretty much repeats what I just said. So Ronnie wasn't going to go through this slide in detail, so I'm not going to either. It's for your reference after the fact. But there's one particular thing that I wanted to make sure that I brought out here. I had a perception going into this presentation that one of the potential downsides of gesture interfaces was that the image sensor was always powered on, that the application processor processing the data coming from the image sensor was always up and running, and therefore a gesture interface approach would be a real battery hog. And what Ronnie told me this morning when we were talking about it was, no, in fact, by using smart software algorithms, smart power management control of the application processor and the image sensor, the incremental battery drain is only 1% or 2%. So that made me warm up quite a bit to the idea of gesture interfaces being meaningful in a broad-based way. And here's some market prediction information from ABI Research. The feature is, they believe, going to be supported in over 600 million smartphones by 2017. And mass adoption will begin earlier in 2014. The Pantech phone, some of you have seen the video clip either in the boot camp presentation yesterday, in the clip I just showed you, or the material that's already on the Embedded Vision Lens website. So, at this point, is there anything on gesture interfaces that any of you would like to also make sure I mention?
How do you do it? I mean, did they modify the sensor? Or is it all done in software? I mean, what's the hardware?
It's all software based.
It's all software based.
Eyesight solution and also point graph solution is based on software.
Okay. So it could be retrofitted to pretty much any existing sensor technology that's out there?
Yeah.
This is for mobile devices, right? The Kinect uses a structured light sensor. There are other approaches in other domains, but in mobile devices.
Well, that's where I was going. I was talking about the mobile. Because it says already commercially available in various smartphones, but that's because people have chosen to implement the algorithms, not go back and build product. That's what I was trying to understand.
Yeah, I'm sure that what we just talked about is why we're going to be in the 600 million unit range within just a couple of years.
I thought everybody was going to get a new phone by then, so.
Yeah.
Well, that's part of the model too.
Is there any trying to put dual sensors in there for other applications, stereo applications, or anything like that? I mean, the sensors becoming so cheap. Why not throw another sensor in there and make it a stereo camera and do much better gesture recognition?
They're working on it.
Is there any
The end user device people are working on it.
It's more common in the rear camera today, right? The dual sensor for 3D still and video imaging than it is in the front.
My time frame's a little different, sorry.
Right.
I'm thinking of it sort of a couple of years out, so those are the people I work with. But, they're all looking at, because you can't do the Connect thing with the phones because you're using a laser and the safety aspects and all that stuff.
And if it's in the front, of course, you can do 3D video conferencing and other related applications as well.
But again, back to my earlier question, you can use a 1 megapixel camera or a 5 megapixel camera. Doesn't require only a 5 megapixel, for example.
For example, the point guard solution can work with just VGA.
Okay.
Depends on quality, and of course it depends on the distance and the level of resolution. If you want to recognize fingers, for example, or just simple motion, just like we saw in the movie, just doing motion detection, it's very simple to do. You need enough low frame rate, so it really depends on the resolution, the level, and the quality of the gesture that you can get.
and your level of confidence.
So,
Right.
It's easier on
I see that gets
So
back.
the answer sounds like the user experience depends a lot on the quality of
It does, yeah.
Of a lot of decisions.
a lot of decisions.
Yeah, there is another issue of what is the use case? Because you have, first of all, you have touch, which is a great technology on mobile, and it's very accessible, unlike on other devices like TV or computer. The far distance is more relevant here. So it's a real competition for gesture to be on mobile device other than the other device, in other devices. We believe that, you know, in terms of experience, if we can bring a new dimension of experience to such devices, like in gaming or even controlling the device, this can be like a real value for such devices. That's why we don't see it. It's already available for a couple of years, but we don't see it anywhere, like in the US and other places, or from very famous brands, because the value there is not fully understood by the market yet.
Any other comments or questions?
I think we're competing against, you know, the voice recognition technologies too, so push them back. I mean, it's,
Okay, so hello, well, it's a lot. My name is Gregori. I'm a software engineer with BDTI, and I'm going to talk about augmented reality and computational photography. So this is a video. This video is actually created by Mateo. I'm going to talk about them in a minute. An example of augmented reality. I was also demonstrating augmented reality in back. And what you can see is as he holds the box in front of the camera, the actual completed Lego model appears in full 3D on top of the box. Now, this is really interesting, and this is, you know, incredibly cool. What you're not seeing here is some of the other videos that you'll find on YouTube. You know, we selected a professional video for this particular audience, but if you go up on YouTube and do a search for Lego augmented reality, what you'll find is a bunch of videos from actual users who've taken videos at the store. And what you'll find is that it's the parents who are more excited about the augmented reality than the kids. So, and what's fascinating about that is these are $200 plastic brick kits that these people are investing in, and the augmented reality gets the parents excited about it. So yeah, if you do a search up there, it's just some of the coolest videos. I mean, these parents are just, they're calling it, one parent called it the magic mirror. They were so impressed and so excited to spend $200 on plastic bricks. And we're going to talk about that because that's where augmented reality has lots of potential. So augmented reality is a concept of superimposing context-sensitive information on top of a view of the real world as seen through a camera. Modern-day implementations of augmented reality combine computer vision with sensor fusion in the cloud to form a virtual view of the world, again, as seen through the camera. So here's two examples of augmented reality. You know, we just saw one, right? It was the Lego. Now notice the Lego demo was running on a PC. Okay, it was in a store. These are two mobile-based augmented reality demonstrations. On the left, we have something called Ion Road. This actually runs on your tablet or your Android phone, or iOS actually. And you actually put your phone up on the dashboard, the camera's looking out your windshield, and by combining GPS information along with camera information, it knows your speed via GPS, and it knows your distance, or actually more importantly, your closure rate to the car in front of you. And it actually pops up a warning saying you're too close, accident potential, or it gives you this green indicating that you're far enough away. There's also lane departure. So using this free app, you can get lane departure in your car. And what it does is it actually uses, and I verified this to make sure, it's actually using computer vision algorithms using the video stream to look for the lane, departure. Actually, it'd be this side over here. Because I was thinking, you know, maybe they're using an accelerometer or something. But no, I was able to verify through quotes from the president of the company that they are in fact using computer vision. On your right, another application, and this is really where augmented reality has a very interesting future, and that's in marketing. Again, you know, in the Lego application, it was the parents who were excited about the augmented reality. Well, with wine, this would probably be parents as well. The idea behind this is that you take your camera, your Android or iPhone, and you go into a store, and this is VDS wines, and by aiming your camera at the label on the wine, you get all this additional information about the wine. Now, I'm not a big wine connoisseur, but apparently, you know, I told the guy last night at dinner, you could give me grape juice, I wouldn't know the difference. But, you know, the region where the wine is, the year, all that information is all available. And this, again, with the way, especially kids and teenagers, if you've got teenagers, the way they're used to interacting with the world, this, you can see how this has a lot of potential. Okay, so be honest, when I first mentioned augmented reality, you know, how many of you guys said, oh God, not that again, it's been around forever, it's never taken off? Well, you'd be right. Augmented reality has been around since 1901, over 100 years. We're still not using it every day. The term itself was coined in 1990, so it's been around for a long time. What's different now, in our modern times, is just within the last few years is the amount of horsepower that's in that device in your hand, that's in the smartphone, that's in the tablet. Not only do you have quad-core processors that can do what a desktop did 10 years ago, but now you actually have accelerometers, gyroscopes, and of course a high-definition camera, megapixel camera. So you can do a lot more with that device that you have in your hand that almost everyone has. So this market research from Juniper, they're predicting, based on that and based on, again, the next generation's expectation of marketing and how to interact with things, they're expecting augmented reality to become a major marketing force in the years up to 2017, starting next year. $300 million, they're expecting it to be a 2.5 billion apps to be downloaded. And again, that's because of the way people coming out of college now expect to interact with their environment. Now both Mateo and Vuforia have tools for helping you create augmented reality applications. On the top I have Mateo. I showed you that was the Lego. That was one of their claims to fame. Another one that Mateo did that's going to become very active relatively soon here is the 2013 IKEA catalog. The 2013 IKEA catalog is actually an augmented reality based catalog. So you can take your iPhone or your Android phone, put it on the catalog, and it comes to life. Now I'm not exactly sure what can come to life in the IKEA catalog, but that's what's happening. Now the Mateo tools, what they tend to push is their tools are for non-developers. So the Mateo tools, they promote it as tools that can be used to create augmented reality ad campaigns for non-developers. On the other side, and also for Mateo, they can do desktop applications, iOS applications, or Android applications. And they also have their own augmented reality-based browser, so they can actually do web applications as well. On the other side, you have Vuforia. Vuforia is from Qualcomm. So Qualcomm first publicly announced their introduction into augmented reality in 2010. They've only been publicly in the market for a couple of years. They've already got 30,000 registered developers, and they have over 1,000 apps in terms of iOS and Android. And they got this really cool NASA app I just found out about today. You can print out these pages, and you take it looks like an iPad device, and you look at the page, and up pops all the spacecraft from NASA. So again, I just found out about it today. Really cool, and it's free. The other advantage with the Vuforia is because it's Qualcomm, it can be accelerated on Qualcomm processors. So you can get better performance on a Qualcomm device, although it works with any ARM. Okay, so what you want to know here is on one side you got underexposed, on the other side you got overexposed. Okay, these are video images. We're going to combine them, and the net result is going to be a higher definition, higher dynamic range image. Okay, it's HDR. So computational photography. Computational photography applies image analysis and processing algorithms to one or more images or frames to create the result that goes beyond the capabilities of the physical sensor and lens. So for instance, up on top, what we have is we took a series of images and we're going to combine them into a single high definition image. Now the way computer vision comes into play is, you'll notice these red lines, those are features. So we're going to use a computer vision algorithm to detect features in each image, and then we're going to line those features up, and that's how we're going to stitch things together. So computational photography uses computer vision algorithms, and computational photography, the algorithms available in computational photography, like HDR, can then be applied and used in computer vision. So why do we care about computational photography? Well, it's because of Instagram, as an example. So Instagram is basically a whole company based on computational photography. How many people here are familiar with Instagram? I'm sure everyone's heard of it. I've never actually tried it. My kids knew about it right away. But the idea behind Instagram is you take a picture, you apply some sort of filter, and then you upload the picture on a social website. It's all computational photography based. Instagram sold to Facebook for $1 billion within the last few months, or this year. They've got over, see, I've got some numbers here. They've got over 100 million users and 4 billion photos up on their site, all based on computational photography. Computational photography is a very interesting technology that's been gaining a lot of interest lately. Shalini mentioned the Franken-Cam, the F-Cam. Again, all based on, the whole point of the F-Cam is a platform for computational photography study. So I showed the video of HDR, and again, it's one of the examples of an algorithm you can use for, from computational photography that we can use in computer vision. So a project that I'm working on now, we have a situation where we were using a low-cost sensor, and we really needed it to work in lighting environments that the sensor just didn't like. Now our solution was, we ended up going with external lighting. But what would be feasible is it's possible that you can actually extend the dynamic range of the sensor using those HDR algorithms. And as a matter of fact, you can actually extend them by up to 12 dB. So you can extend them quite a bit. So you can see where these computational photography algorithms like HDR can become inputs into our computer vision system to help augment lower cost sensors. So anyone who's ever been to one of my presentations knows I cannot do a presentation without mentioning OpenCV. My apologies. But in this case, it's a different story. We're going to talk about OpenCV for a quick second, but what I really want to talk about is NVIDIA's contribution to OpenCV. Okay, and OpenCV in the smartphone arena, Android and iOS. So OpenCV has been ported to Android and iOS, and there's a project called OpenCV for Android that was actually created by NVIDIA. And what they've done is they've created this whole system around OpenCV where what you can do is you can take a piece of hardware, right? You can use the NVIDIA, you can write your application in OpenCV, and this piece of software called the OpenCV Manager will automatically detect your hardware type and download the correct libraries for your particular hardware. You don't have to rewrite your OpenCV application. So now, if I take my OpenCV, and I've actually done this, I take my OpenCV application, I write it for my Nexus 7, which is a Tegra 3. It automatically detects it as a Tegra processor, loads the Tegra optimized library. I take it to my Nexus phone, which is the TI OMAP 4, and it uses the standard OpenCV library for the OMAP without changing the application at all. It's a very nice tool, and it's going to make OpenCV very popular in the smartphone market, because that's one of the biggest problems. The smartphones, especially in the Android side, it's all over in terms of processors that you can use. And this tool, this OpenCV Manager, makes that significantly easier to work with. Now I mentioned NVIDIA, and this, I think Shalini also mentioned this, is the Tegra Android Development Pack. So not only has NVIDIA contributed a lot to OpenCV, but they've also created this TADP. The whole point of TADP is to make developing on Android devices easier. You basically install TADP on your PC, whether it's Ubuntu Linux 64, OS X, or Windows, and it's an auto installer. It automatically goes out, gets all the development tools that you need, installs them on your machine, and you're up and running, ready to go. And it works for both Tegra devices and non-Tegra devices. So even if you're developing Android applications for a TI OMAP-based phone, you can still use this tool. Oh, I wanted to mention one more thing. Oh, as part of that port that they've done, they've actually optimized OpenCV. And again, I actually need to talk about this. They've actually optimized OpenCV to accelerate it for Tegra processors. So it actually takes advantage of the Neon coprocessor and the GPU shaders. And on that note, Vidiantis. These guys in the back corner. My apologies. I knew I was going to get that wrong. They've done the same thing. So if you had a chance to see their demo, they've got a multi-DSP core processor that they've also optimized the back end of OpenCV for. So what OpenCV, what you can do is you can write an application in OpenCV, build it for their processor, and they replace the back end is what they're doing of OpenCV to take advantage of those DSPs and accelerate it. So I'm sure they've got examples of OpenCV running without their acceleration and with their acceleration, just like NVIDIA does. NVIDIA's got a really cool demo you can download right off the Android marketplace. And finally, Qualcomm. So Qualcomm has their FastCV library. Now you can actually use FastCV with OpenCV if you want. But what FastCV does is it works with either a regular ARM processor with a Neon coprocessor, or it works with their Snapdragon processor. Now where FastCV gets really interesting is how much they've optimized it for the Snapdragon processor. FastCV is designed in such a way that if you are running it on a Snapdragon, it can not only take advantage of the CPU, but the GPU, the on-chip DSPs, and the VNUM, which is their superset of the Neon coprocessor. So again, their software, if it detects that it's on a Snapdragon phone, runs better. If it's not on a Snapdragon phone, it takes advantage of at least the Neon for the non-Qualcomm part. So in this presentation, we've talked about, the core of this presentation is really the smartphone market and the tablet market. We see this market growing. Smartphones and tablets outsold the desktops. Recently, it was last year, 2 years ago. The exciting thing to develop on right now, if you're a college student, is a smartphone. We're already starting to see that algorithms are starting to get developed more and more towards smartphones, or they're being released on smartphones at least. So we see the smartphone as sort of being the cool new system to design for in the future. The tools are very robust, very mature, and what's great is they're free. So you can't beat that. And with the horsepower that you have in smartphone systems nowadays, what you can actually do on them is very impressive. There's examples right now up on iOS of augmented reality, of computational photography, again, for both Android and iOS devices. And you can just download them right off the store, in my cases, for free.